A structure consists of two types of members, trusses and frames, in which truss is a articulated structure composed of straight members arranged and connected in such a way that they transmit only axial forces. For this, a truss is made up of several slender bars called members that are joined together at their ends by hinges or rivets. The bar members therefore act as two force members which can either be in tension or in compression. There can be no transverse force in a member of truss, as you can see in this particular figure. Now, for the sake of calculations, the joints are supposed to be hinged or pin jointed, and a truss is designed to carry loads at these joints. Otherwise, truss members can be subjected to lateral loads, which is undesirable. Now, these joints are also known as nodes. If you are familiar with civil engineering softwares like StatPro or ETABS, you will come to know that these joints are called as nodes in those softwares, but they are basically joints itself. Now, a perfect truss is composed of least number of members to prevent distortion of its shape when loaded. If the number of nodes in a perfect truss is n, then the minimum number of members would be 2n minus 3. We are not getting into the explanation behind this particular phenomena, behind this particular deduction, because being a mechanical engineer, our aim is to understand the mechanism in behind. Next is frame. See, a frame consists of members which can be subjected to a transverse load in addition to axial load. In case of truss, only axial load was being examined or was being transmitted, but in case of frame, both transverse and axial load comes into play. Therefore, the members of a frame carry load at points other than nodes as well, or basically joints. Now, if load is applied at a point other than a joint, the member is subjected to bending, and in such a case, the force in the member is not purely axial. That's why transverse loading is also present. To find the forces in the members that are getting subjected to bending, the equilibrium of each member is considered separately by constructing what? Free body diagrams. Now, there are certain assumptions in case of the axial forces that are being developed in truss members. That is, first, each truss is composed of rigid members all lying in one plane. Secondly, forces are transmitted from one member to another through smooth pins fitted in the members. Thirdly, all the loads are applied at the joints but not in the members. If a load is being applied in a member, then that particular phenomena, that particular instance, we will not call it a truss, we will call it a frame. And fourthly, weight of the members are neglected because they are small in comparison with the loads.